I made this video before I realized exactly what order things were in, so it starts a little bit jumpy, but it should cover exactly what we need for analyzing graphs of variations of sine and cosine. And in this video, we're going to be looking at how to find the equation if we're given a graph. And because this is a sinusoidal function, you can tell just by looking at it, it's either going to be a sine or a cosine. And you can actually find an equation for this graph using either sine or cosine. But oftentimes there's one that's going to be a little bit easier than the other. So what I'm going to do here first is try to find places where the graph crosses the x-axis, and those are potential places where we could start thinking about this either being a sine or cosine function. So this graph crosses the x-axis at -6. That looks like about 1, and then 4. And if we look, we can see that it takes from -6 to 4 to complete one cycle. So that's going to tell us something about the period of the graph. We could also look at this as going from -11 to -1. Okay, those are both sine functions. Starting at -11 and going to -1 is one sine function, or one way of looking at this sine function. Going from -6 to going to 4 is another. But in the first case, I went up first. In the second case, I went down first. So if I choose starting at -6, then I'm going to have to use a negative in my equation because it's a negative. Sine functions normally start by going up, right? I could also start at -16. I could also start at 4, but I don't have enough of a graph to figure out from here what a cycle is. So the other thing we could do is start at the highest possible point, which is 4 here, the bottom being -4. Start at the highest possible point and see that looks like it's 8. There's 9 right there. -9. So it looks like we're at about -8.5. And so if we wanted to use a cosine function here, we're going to kind of have to guess at what the x value is here. What is the input value that gives us that maximum? And it's going to be very much an estimate. And so it's not going to be very accurate. Because of that, I'm going to suggest that this is a sine function and not a cosine function. It could be written as a cosine function. Let me be clear about that. It can be written as a cosine function because sine and cosine are just shifted one from the other, right? But it's going to be easier to write it as a sine function. So there are a couple of things we have to do here. Recognizing that these all take the form y equals a times either sine or cosine of b times x minus c plus or minus d. Now we've already decided this one's going to be easier to graph as a sine function. So I'm going to rewrite this as a times the sine of b times x minus c plus d. And you now have two versions of this, and we're going to change this one. I'm going to erase the a once we figure out what it is. I'm going to erase the d once we figure out what that is and change and replace it with its value. All right, now I think it's pretty easy to see what a is going to be, because we can see that instead of going up to a value of 1, the maximum value of the graph is 4. So it's clearly been stretched, not just in this direction, but also in this direction. So I am pretty confident that a is 4. Now, something I've already mentioned is that we could think of this sine function as starting at -11 and ending at -1, or we could start at -6 and end at -4. It's entirely up to you which one you want to do. Which one we decide will determine what c is. If we decide to start at -11, this will become +11. If we decide to start at -6, this will become +6. The difference it will make is if we start at -11, we'll have a positive sine graph because it goes up first. If we start at -6, we'll have a negative sine graph because it goes down first. So because I get a full cycle before I even get to 0, and also because it makes it a little bit more complex, and I want to show you a slightly more complicated version, I'm going to go ahead and start at -6. That means my sine graph, instead of starting at 0 and going up, starts way over here. And it starts from there, it goes down. It might have gone up. If it wasn't negative, it would have gone up, right? So it starts way back here. That means I'm going to make this plus 6. So let me erase my minus c. I lost my x in there as well. My eraser just got really big for some reason. X plus 6. And the reason for that is that we're not starting here, we're starting way back here. But the other thing is that we're starting here and going down instead of going up. So I'm going to add a minus to this, to the a value. All right. Now, if this were a test, for example, you'd have partial credit already, because although we haven't figured out what B and D are yet, you have figured out the 4, which is how far it's been stretched. You've figured out that it's starting negative if you start at 6, and you figured out that 6 is a good starting point. Minus 6 is a good starting point. So that's 3 of the 5 things that you need to know. 6 if you count, you need to know whether it's a sine or a cosine. So you're at least halfway there already. Now, another thing to look at is how far this thing has been shifted up or down. If I were to draw a line that cut the graph in half in terms of where the part of the graph that goes above the halfway mark and the part of the graph that goes below the halfway mark, I can do that in this case right along the x-axis, because now you can see that from here the graph goes up to 4, and from here it goes down to negative 4. From here it goes up 4 units above this line here, and it also goes 4 units below this line. That won't always be the case. Sometimes this line will be shifted up, and it'll go up 4 from there and down 4 from there. If it went up 4 from here, it would go up to 6. If it went down 4 from here, it would only go down to negative 2. So you need to figure out what that line is. In this case, that line is just the x-axis, which means it has not been shifted up or down. That tells me that D is 0. So I can either write here plus 0, or I can just leave it empty. Right? You can write it like this, or you can leave it blank. Now, on a test, you might actually want to write plus 0, just because that helps to indicate that, to me, that you know it hasn't been shifted up or down. All right, let me erase my pink line here. Actually, before I do, let me point this out. There's a little bit of vocabulary going on here that we haven't covered yet. This line right here is called the midline of the graph. The midline is the graph that the line that cuts the graph in half horizontally. Half of it goes above that line, half of it goes below that line. In this case, that happens to be the x-axis, but it won't always. So midline is an important vocabulary word. Another vocabulary word we haven't discussed is that the a value here, the amount which it's been stretched from a highest point being 1, in this case to the highest point being 4, that's called the amplitude. And there are a couple of different words for the horizontal stretch. Sometimes you'll see phase shift for horizontal stretch. And sometimes it'll just be called horizontal shift or horizontal, I guess horizontal shift. And vertical shift is just called vertical shift. But the vertical shift is affected by the midline, or you might say the midline is affected by the vertical shift, okay? In fact, it's the midline that tells you what the vertical shift is. All right, so what have we got left here? We have B. I think B is the only thing we have left. And the question there is, how many cycles does it take to go from 0 to 2 pi? In other words, how many copies of sine can we get between 0 and 2 pi? Normally, sine takes 2 pi to do one cycle. Here, that's not the case, because 2 pi is a little over 6. So if we start at negative 6 and go to 0, the whole graph should fit in about that amount of space. In this case, though, to complete a full cycle, you have to go all the way from negative 6 to 4, right? So it actually takes 10 units, these 6 plus these 4, to complete a cycle. So we can think about this as, I'm going to call, let's put another vocabulary word up here, period. We already know what period is. It's the length of it's the portion of the x-axis or the t-axis that it takes to complete a full cycle. So the period here is 10, wrong pen, my apologies. The period here is 10, okay? And I'm going to call period, I'm going to give it the abbreviation P. Normally it's 2 pi. On an unmodified graph of the sine function, it would be 2 pi. Here it's not, and so we have to figure out how are we going to how are we going to chop up 2 pi in order to get the period that we're expecting, okay? What we want to do is figure out what this number is, and then once we know what that number is, we'll be able to say, well, normally it takes 2 pi, and so we're going to chop 2 pi up into b units, and we're going to divide one cycle is only going to take b units, and that's at 2 pi divided by that number, okay? So this is kind of an equation that you can use to do that, except that in this case, we know what the period is. It starts at -6 and goes to 4, or it starts at -16 and goes to 6. So the period is 10 because it takes 10 units to get from the beginning of one cycle to the end. So I can actually erase the p and replace it with 10. And then I can solve this equation, multiplying both sides and then dividing both sides by 10. I get b equals, I can reduce this, pi over 5. So now I can replace my b with pi over 5. And there's my solution. There's my equation for this graph. Now, that tells us how to find the equation if we're given a graph, but how do you graph a sinusoidal function if you're given the equation? And hopefully you'll find that fairly straightforward. It's a little bit involved. There are a lot of steps, so we're going to do that. The next topic is called graphing variations of sine and cosine, so we're going to go to a different video to do that. But that's our next topic for conversation, and I'll see you in the next video.